Focus करो. Now we are going to see this frequency response for low pass filter.
वही नहीं है सर.
ठीक है ना, रिकॉर्डिंग करना है.
अच्छा आपने वो यूट्यूब पे लिखी है.
कोई कुछ issue नहीं.
पॉज कर डबल चल.
It's fine. So we are going to see the frequency response for low pass filter, and this is a constant K type. So this is the circuit you can see. So here we have to use one inductor and one capacitor will be in parallel. Okay, so here there is no component. So we have to manually select from these four inductor banks, and one capacitor we have to select from these two capacitor banks. And here there is one more provision for additional inductor. So we have to short that. Okay, so let's make connections. So we have shorted this, and now let's select the inductor. So we can select any one inductor. So this is the inductor we have connected, and now we'll connect the capacitor. So we have connected one terminal for capacitor. So let's connect second one. So this is the second terminal we have connected. Now all components are connected. Now the remaining is we have to connect the output, and here there is a input which should be connected from function generator. Function generator means this is the signal generator through which the signal is connected, and this should be connected to the output, because from function generator the output is generated, that is frequency, and that is to be connected here. Okay, with positive and negative. So let's connect one positive, and we have to use the crocodile pin. So we have to connect this positive to the input. So this is positive, and we'll take one more, the ground. So this is the ground. Okay, now we have connected with the input. Just make sure they should not touch each other. And now let's connect the output. And now what we have to do, as per the observation table. So here we can see in the observation table, we have to measure the input voltage also that we have applied here through function generator. And at the same time, we have to measure the output voltage also V2 that we are measuring across the output terminal. Okay. And we have to measure the input frequency. Continue. So we have to take the reading for frequency also. Okay. And what we have to do, as we are giving the input, same input we have to see it on the DSO. Okay, this is the digital oscilloscope, which has more accuracy. So we have to see on this one. So this is channel 1 and this is channel 2. So we have connected two crocodile pin, that is two channels. So this is our channel 1. So we'll connect this to the input, okay, where we are given the function generator input. So that at a time we are giving the input, and at the same time we are observing it on the DSO. Okay. So let's connect this positive to the same and negative to the same here. So this is the connection, and now we have to connect the output. Okay, again we'll connect two wires. Okay, one is sufficient here. Okay, just we'll connect this ground with this channel 2, this ground, and as this is the pin, so we'll directly put it here. So this is our complete circuit. Okay, now let's turn this on. Okay, now that is on, but you can see the signal is 0 because the function generator is off. Okay, so now let's turn this on. Okay, now here you can see the current frequency is 3.2 kilohertz, and here you can see there is a white color button which selects the range. So now if you have to vary the frequency from this variable frequency variable. So now currently it's at maximum, so we can reduce that. Now you can see the frequency is changing. But suppose I want more than 3 kilohertz. So what I have to do, just once I have to click on this white button so that the range of frequency is getting increased. Now you can see it is changed to 30 kilohertz. So that is the maximum value. Further we'll change it again for higher. So now it's a 3 megahertz, or I think it's a 0.3 megahertz. Once again, now it is 3 megahertz.
3 hertz.
Now it's a very small, that is 3 hertz, which is 30 hertz. Now it's a 0.3 kilo and 3K. Now what we have to do, we have to set the frequency. We can take the reading from 500 hertz, then 1K, then 2K or 2.5K. So we can take the readings accordingly. Okay, let's keep this 530 hertz. And now you can observe on this DSO, digital oscilloscope. You can see there are two colors, and there you can see the two three different frequencies are there. And this is the panel where you can see all the readings like peak to peak voltage and other parameters. Okay. Now what we can see, one signal is there, but second signal is going beyond the screen. So we have to set that. So we have to set the signal. So this is channel 1. It's a voltage that is vertical amplitude. So if you increase this, you can see the yellow color, that is for channel 1. Its amplitude is increasing. Okay, we'll keep this as it is. Now we can see the second, that is channel. Its amplitude is going beyond the screen. So we have to reduce that. So let's reduce that. So we have to move it to the left direction. This knob. Now you can see they are overlapping. Now here we can see the reading for channel 2. But so here we can take the peak to peak voltage. It is 16.8 volts. But I want for channel 1. So what I have to do? So this is the corresponding channel 2, and this is the button. I have to press this. So you can see the reading is changed from now it is for channel 1. So these readings we have to note down corresponding to each frequency. Okay, like this we have to take 10 to 15 readings so that the graph will be plotted. And you can see this is the observation table. After getting 1, 2, 3 readings, you have to find out the half power frequency, that is alpha, which is equal to 20 log of V2 upon V1. Okay, so this calculation to be done, and these points are to be calculated on the graph paper or simple paper as per convenience. So that will be the final result. So this is for, it's a low pass filter. So in the same way, we have to perform for high pass filter also. You can see, and only the observation table is also same. Only what is the difference in low pass and high pass? So this is low pass filter. Here we have used inductor in series, capacitor in parallel. But in the case of high pass filter, just we have to interchange. The inductor will be replaced by capacitor in series, and here the inductor will be coming in parallel. And this short we have to make it as it is. And same setup we have to make, and we have to take the readings. Okay, so thank you. Okay. Stop it.